Hey, so welcome back, and this is another daily code problem. So today it's called longest increasing subsequence. This is a medium level dynamic programming problem. So essentially you're just given an array here called nums, and you're going to do exactly what the title says, and it's a maximization problem where you want to find a sequence that's in increasing order, and you want the longest one. Now what increasing means is just at every step, the one to the left of the current number or to the right of the current number is greater than it, and it has to be strictly increasing. So you can't say have like 7 comma 7 in your subsequence. It has to be like 7 comma 8. So it has to be an increasing and strictly increasing. All right, and so there's one other trick here, and that's that we're dealing with a subsequence, and this just allows us to actually jump over numbers. And so in this case, you can see that 3, 7, 101, that's a valid sequence of 3, that's in an increasing order. But we can also include 2 here by skipping over 5, and that then gives us 4, which happens to be like the longest increasing subsequence for this problem. Now initially I did a top-down memoization approach because I kind of viewed this as at every point in this array you can have 3 different choices. So say if we're viewing like this subsequence here, at every point you could either say, okay, say we're currently at 2, we can either then say, okay, why don't we include 2 comma 5, or we can do 2 comma 3 and skip over 5, or we can just say at 2, let's just forget about 2 and just start at the next one. And these are 3 different choices that we can make at every point in our graph. And this was okay, but I got a memory limit exceeded here because my parameters are just too far verbose to be caching it, and so this doesn't work. You kind of have to do more of a bottom-up approach. You might be able to make this work by finding a way to restrict the size of your parameters, but I just went with a bottom-up approach, which I'll show you now. And so essentially, typically whenever you translate from a top-down to a bottom-up approach, you're going to say, okay, we're going to want to return some result from our DP array that we're going to create. And so let's initially set this as 1 because the values are going to represent what the current longest increasing subsequence is that you can get from this point. And so you're going to say, okay, let's multiply this by the length of the numbers, which we can just set here. And so generally you just say, okay, I like to do from right to left usually. You can often do from left to right or however you want, but this just was very intuitive for me. So let's just say, okay, for I in the range, and we're going to start at the end, and we're just going to iterate backwards. And so we're going to use 2 pointers here. So we're going to do something similar for j, but instead we're just going to go from I plus 1, and we're just going to reach the end of the array. So that way we can just bring our I pointer to the left each iteration, and then just like iterate between the values in that subrange that you're looking at. And so with each iteration, we just want to consider, okay, if the number at I is less than the number at j, and we have to make sure it's not equal to, because it has to be strictly increasing, then we're going to consider it at this point. So then we say, okay, the maximum at this point in this array is going to be equal to itself or from the point that we just found plus 1. And so that kind of symbolizes, okay, let's jump to this point from j. And then all that you're going to want to do is, well, we want to consider all the possible increasing subsequences. So let's just take the maximum of our DP array, and that will get us what our maximum increasing subsequence is. So let's submit that. And success. So yeah, I hope that helped, and good luck with the rest of your algorithms. Thanks for watching.